Hello everyone, my name is Evgeny and you are once again on the TM Zenatan channel. In today's video I want to show you how my homemade milling machine for processing the side edges of our staves for our oak barrels is built, and how to calculate the angle of the side edge of our staves. If you're interested in how to calculate the required number of staves for our barrel, as well as how to make the bottom, how to cut the groove for the head, how to make the hoofs, and the entire process of making a barrel from start to finish, visit the channel, subscribe if you haven't already, and watch. I made my milling machine from an ordinary angle grinder. The angle grinder is 2 kilowatts, designed for a 230mm disc. The gearbox in this angle grinder was broken, but the electric motor is in excellent condition. To make the homemade milling machine, I cut off part of the gearbox housing. Then I cut an Epton thread with a pitch of 1 mm onto the motor shaft. This same thread was on the chuck for the collet. The chuck was bought separately from some kind of milling machine. I don't even know which one. The collet has a diameter of 8 mm. For this collet, I got a straight bit with a guide bearing like this. Everything is secured, and in fact it has been working for quite a while already. Considering that the length of our shaft with the chuck and the bit is quite substantial, and in order to eliminate any possible vibrations and for safety reasons, I made this kind of steady rest. I drilled 3 holes in a regular angle bracket, plus a central hole for the bolt that clamps the guide bearing. In this support, a hole was made here that exactly matches the diameter of the guide bearing. This device is put onto the guide bearing. On the other side of the angle bracket, 2 longitudinal holes were made so that our device can be attached to the matching angle bracket, which is made in the form of small bracket. For what purpose? So that the tilt of the router can be adjusted, thereby changing the angle that can be given to the side face of our rivet. To attach our router to the table, a device like this was made from a piece of metal. The profile of our electric motor was cut out. And considering that there are these protrusions on the gearbox itself, with the help of this device, it is very convenient to secure our router. In other words, everything is quite reliable, it won't go anywhere. 4 spaces like these were made, which fit onto these points, and an additional plate like this was made, which as a result clamps our router, our electric motor, through these spaces. And with the help of studs like these, the whole assembly is fastened to the router table. The router is firmly attached to the aluminum tabletop. This is the kind of aluminum sheet I used as the tabletop. And with the help of 4 studs, the router is firmly attached at a certain angle to the tabletop itself. To control the speed, I use this kind of regulator, which I bought online. And now I'll show you how our router's speed changes. The construction is quite simple and fairly reliable. Before we start working on our stave, we need to determine the bevel angle of the side edge of our stave. To find this angle, we need to know how many staves we will use as the base of our barrel. For the base of my barrels, I use 21 staves. Since a circle has 360 degrees, we divide 360 degrees by 21 staves and then divide by 2. This is because each stave has 2 side edges. As a result, we get the bevel angle of our side edge, which is 8 degrees and 36 minutes. I set the calculated angle on our protractor. As you can see, 8 degrees and 36 minutes. I made a template for this purpose. On one side, I have an angle of 8 degrees and 36 minutes for 21 staves. On the other side, I have an angle of 15 degrees for 12 staves. That is, our little template matches exactly. With our protractor, we have set exactly the same angle on our milling machine. Initially, I used this kind of milling table setup to process the side edge of our stave. But then I faced the question, how do I adjust the changing angle? We can change the number of staves. We can make a barrel with fewer staves, not necessarily 21. To do this, we need to adjust the tilt angle of our milling machine. It would be possible to make an adjustment using studs to adjust the milling machine itself, but that's quite inconvenient. So I decided to make an adjustable tabletop. Here I have already made the tabletop, which will be mounted roughly like this and will allow us to adjust the required angle. To see how this turns out, keep watching. Friends, let me briefly explain how I carried out my plan. I firmly attached an oak rail to the aluminum tabletop. To this I will attach a tabletop like this one, made of some kind of plastic. I attached 2 of these brackets to this tabletop. Here I made 2 technical holes so that I can fasten this tabletop to our outer table with 2 screws. Now the tabletop is installed. Now, through these technical holes, I secure our adjustable tabletop with 2 screws, and as a result, what do we have? We have an adjustable tabletop for our table. When our plastic tabletop is lowered all the way down, we have, here is our template, we have an angle of 15 degrees. But when we raise our tabletop, our template will match an angle of 8 degrees and 36 minutes. Not the template, but the angle, to be precise. Thus, on this milling table, it is now possible to mill the side faces of our stave at different angles, from 8 degrees 36 minutes up to 15 degrees. You can also set any intermediate angle within this range. That is, we can use anywhere from 12 to 21 staves. So I have set up my safety system. Now the cutter is securely protected. Next, I fixed the tabletop at a 15-degree angle. In the future, I might adjust the tabletop for different angles, but for now, to keep the design simple, we just unscrew the bolt that secures our adjustable table and place a strip like this under the table. That's it. Our table is set at an angle of 8 degrees and 36 minutes. Later, by adjusting the thickness of the strips, I can set it to the angles I need, so I don't have to unscrew the bolts and set the angle every time, but instead know that each strip corresponds to its own angle. I think this way will be much more convenient. So if you like the video, give it a thumbs up, share it with your friends and subscribe to the channel. See you next time.